Welcome to today's lecture. Today's lecture is mainly on microbial quality maintenance of milk, that is mostly after collection, then transport and then storage before processing or before pasteurization. So we will discuss about the hygienic handling of milk during collection and the microbial growth and different factors and phase of growth of microbes, and then we will discuss about the transportation and microbial growth during transportation and factors affecting the growth and how to control the microbial growth during transport. And finally we will discuss about the storage of milk in the dairy plant before pasteurization, so that is the pre-chilling, and there we will see the factors affecting the microbial growth and how to control the microbial growth during storage of milk in the dairy plant before pasteurization. First is milk handling in farm. That is the after milking, how the milk is handled. That is very important. So preserving the quality of raw milk is a problem in the farm since contamination is unavoidable. The atmosphere in the farm is always challenging to prevent the contamination of milk due to the environment, the cows around and the other aspects. The solution rests in hygienic milking and handling practices. There are more details which we will discuss in the topic like clean milk production. So there we will discuss how to have the proper milking shed, hygienic handling of the milking utensils and other practices, and maintaining the clean cow. And secondly, the cooling and holding of milk at a low temperature to retard the multiplication of microorganisms. That is, after milking, the milk should be cooled as early as possible to a temperature which will maximum prevent the growth of microbes which causes the spoilage of milk. Now we will discuss about milk chilling duration, that is the gap of milking and the chilling. That duration is very crucial. Milking normally takes place twice a day, morning and evening around 6 a.m. and 6 p.m. but cans are collected once a day in the morning. So what happens? The age of milk on arrival at dairy is 3 to 4 hours for the morning milk and 15 to 16 hours for evening milk. During this time, microbes can multiply. So that's a challenge. The morning milk reaching to the chilling center or dairy plant within 3 to 4 hours. However, the evening milk is delayed. So that's a challenge. And in such case, there is only one solution. 2 times collection is better practice to avoid this problem. Bacterial growth in milk. Since this topic is only on microbial quality of milk, in which the bacterial contamination is unavoidable during the milking and handling with the utensils and other things. Hence, the bacteria in milk remain in lag phase during the first hour of milking, resulting in slow multiplication. So, bacterial growth has several phases, in which first phase is called lag phase, which is very slow, and the next phase is the log phase, during which it grows very fast. We are going to discuss little later. Duration of lag phase is extremely variable and mainly depends on initial level of contamination and temperature of storage. So this lag phase, how long it will be, it is variable, and that depends on the level of contamination. That is, how much is the microbial contamination happening, the load at the beginning. That is very important factor for the duration of lag phase, and also the temperature at which it is being held. So if the temperature is little bit higher side, then this lag phase will be slower and it will quickly go to the log phase. And partially this bacterial growth, that is the lag phase, depends to a lesser extent on the composition of milk, because there is not much variation within the same species, whereas in between the species there are variations. So milk as such is a very rich nutrient and very conducive for microbial growth. So that is of course to a less extent affecting that. So microbial growth has four phases, that is from the growth curve you might have learnt earlier, that is the lag phase, log phase or logarithmic phase, then stationary phase, and then stage of decline. So this log phase is the very first. So lag phase is succeeded by log phase, during which microorganisms multiply very quickly, causing fast deterioration in milk quality. So this is the phase where the microbial growth takes place very fast. During this phase, precautions are necessary to preserve the milk quality. And any intervention after this period, when the microbes are in the log phase, is almost negligible effect. So once the microbes reaches the log phase, it will multiply very fast, and at this stage if we try to intervene, it may not be very useful. So this is very important for maintaining the microbial quality of milk. Now duration of log phase, that is how long it will. So earlier I have mentioned it depends on the initial microbial load. So it can be 10 to 15 hours for very clean milk which is having very low microbial contamination, that is about 1000 CFU per ml, and held at temperature 20 degrees Celsius, that is little bit higher side. Whereas it is 2 to 3 hours or less in highly contaminated milk having several thousand of organisms per ml. Therefore, in practice, within first 2 hours of milking, means of arresting microbial growth must be applied. So to stop the fast microbial growth, that is the log phase, we must keep the milk at a lower temperature within 2 to 3 hours. Otherwise the log phase will come when the microbial growth is microbial contamination is very high. The log phase will be starting within 2 to 3 hours, and then it will grow very fast and milk will be spoiled very quickly. So all measures to prevent microbial growth should be applied within 2 to 3 hours. Now we will discuss about hygienic handling of milk. Careful handling of milk after milking is necessary. Milk should be immediately cooled to 10 degrees Celsius or below after straining to remove any visible dirt. So it is already said that the temperature is important, so we should try to bring down the temperature at the earliest possible after milking. And straining is to remove all the visible darts which is the source of contamination. Next is keeping feed and weed flavors out of milk. So milk will always absorb outside smell or odor. So if there are any feed or weed or even the clean shade is very important, all these things can impart the bad odor that will be absorbed in the milk. And thirdly, proper cleaning, washing and sanitizing of milk cans, milking pails and strainers. So all these utensils which are directly coming in contact with the milk must be properly cleaned and sanitized so that it will not add any contamination to the milk. Now we will discuss about the temperature and bacterial growth. You might have studied already in general microbiology, that is the bacteria broadly can be classified into three categories, that is the mesophilic, thermophilic and psychrophilic. So mesophilics are the most common, which can grow at around 30 to 40 degrees Celsius, whereas psychrophils can grow at 10 degrees Celsius or below. A critical temperature for milk is 10 degrees Celsius. Therefore, raw milk should be promptly cooled to 10 degrees Celsius and preferably to 5 degrees Celsius or below, and also held at that temperature till processing. So milk, as there is high contamination, is unavoidable. We have to stop the bacterial growth, for which the temperature is the major factor. So if we can bring the milk earliest at 10 degrees Celsius, it is good, and at 5 degrees Celsius is better. At 10 degrees Celsius, microbial growth in milk is comparatively rapid than at 5 degrees Celsius. but the difference in the rate of growth is very high at 15 degrees Celsius than at 10 degrees Celsius. So these are some of the basics for the microbial growth. That is, main is the temperature. So our motto should be to reduce the temperature at least 10 degrees Celsius or below, or even 5 degrees Celsius is better. Here we can see the effect of temperature on the microbial growth. As I said, it is the major factor. We can see in the left column the milk is held at different temperature for 18 hours, and in the right side the growth factor, that is how much times of growth happen. In 0 degree in 18 hours, that is the considered as one that single time, and then when it is at 5 degree it can be multiplied by 1.05. At 10 degree it is multiplied by 1.8. At 15 degree it is 10 times higher. In case of 20 degree it is 200 times, and at 25 degree it is 1,20,000 times multiplication is happening. So this is the factor in which we can multiply the number of organisms growing at different temperature for 18 hours. Here we will discuss about time, temperature and bacterial growth. As I mentioned earlier, the temperature is the major factor, and the second factor is the time. So based on time, the bacterial growth will change. At storage temperature of 2 to 4 degrees Celsius, there is a drastic change in the microbial flora at a storage time between 60 to 72 hours. That is, if we hold at 2 to 4 degrees Celsius and for 60 to 72 hours, the profile of microbial flora changes. So as I said earlier, only the microbes which can grow at lower temperature, their population will increase. On the first day of storage, 1 to 10% microorganisms were psychrotrophs. But after a storage period of 2 to 3 days, these organisms completely dominate, and less than 1% consisted of coliforms. So this is in some experiment, it is found that when the milk is kept for 2 to 3 days, the psychrotrophs increased heavily, whereas at the beginning they were only 1 to 10%. So psychrotrophs means those organisms which can grow at low temperature. At lower storage temperature below 10 degrees Celsius, the milk may appear normal for 2 to 3 days, although there is considerable microbial multiplication. So when we are storing the milk at 10 degrees Celsius or below, milk may not be spoiled. It may look normal, but large number of microbial growth will be happening due to the growth of psychrotrophs, but still it is not really spoiled. Here is some more observation about the time, temperature and bacterial growth. Thermodiuric Corynebacterium and micrococci derived from milking equipment do not multiply in raw milk within 24 hours at 12 to 22 degrees Celsius. So these two organisms, they are pathogens or spoilage organisms, but they cannot grow at 12 to 20 degrees Celsius within 24 hours because they are thermodiuric. The minimal external microbial contamination results in smaller increase in microbial numbers on storage over a wide temperature range as compared with heavily contaminated milk. So if the milk is having very minimum contamination, in that case the microbial growth will be very less, or microbial number will be very less even at a wide temperature. But if the initial microbial load is very high or contamination is very high, then they will grow very fast. This might be due to natural antimicrobial properties of milk to some extent. So this difference to some extent is due to the some antimicrobial properties present in the milk when the number of microbial contamination is very less. The bacterial multiplication is delayed even in moderately contaminated milk for 2 to 3 hours at 30 degrees Celsius and for longer period at lower temperature. So when the contamination is at moderate level, still 2 to 3 hour milk will be okay at 30 degree, and it will stay even longer period at a lower temperature. Here we will just see a growth of microbes at different temperature at different time interval when the hygienic condition is very good, that is the clean cow, clean environment, that is the shade, and the clean utensils. So we can see here three different temperature, that is 4.4 degrees Celsius, 10 degrees Celsius and 15.5 degrees Celsius. In the fresh milk we can see microbial growth 10 power 3 same for all. In 24 hour the microbial growth is almost same in 4.4 and 10 degrees Celsius, whereas in 15.5 it is 1.59 into 10 power 6, that is 100 times more. At 48 hours we can see the 4.4 it is 10 power 3, whereas in 10 degree it is 10 power 5, that is 100 times more. And in case of 15.5 it is 10 power 7, that is 10 power 2 plus 10 power 2, that is the 10,000 times more than the first one. In 72 hours it is again 10 power 3, 10 power 6, 10 power 8, so another 10 times more in case of 15 degree and another 10 times more in case of 10 degree. At 96 hours we can see 10 power 4, 10 power 7, 10 power 8, that is in case of first 4 degree there is only 10 times increase, in 10 degree there is another 10 times increase, so total it is 1000 times more than the first one, and in 15 degree it is another 10 times increase. So we can see the difference in microbial growth at different time interval at different temperature. Here once again we will see the relation of temperature and duration over the microbial growth, and here the situation is reversed, the dirty cows, dirty environment and dirty utensils. So how it is affecting the microbial growth? You can see in case of 24 hours the number of microbes is higher. Even in the fresh milk it is 10 power 5. In 24 hours it is 10 power 5, 10 power 6, 10 power 7. In 48 hours 5, 7, 8. In 72 hours 10 power 5, 10 power 7, 10 power 9. And in case of 96 hours 10 power 5, 10 power 7, 10 power 9. So roughly we can see in 72 or 96 hours the microbial growth is 10 times higher, 10 times higher due to the dirty situation in cow environment and utensils. So these results depicts the impact of the hygienic conditions and the time temperature for microbial growth. So here we will see the system of milk transport, because we are concerned about the microbial quality and the maintenance of quality, in which there are three phases. One is the milking place, and then it is collected and going to temporary collection point, or sometime it is going to the dairy plant, and then there it is stored for some time and chilled, and before it is going to the pasteurization. There are different situations which we are going to discuss later about maintenance of microbial quality. So here we can see four kind of transport. Number one is transport in milk cans directly from the producer or from collection points to the dairy. Number two is transport of milk in bulk collection tankers directly from the producer to the dairy. Number three is collection from producers in small collection tankers and pumped into a large tankers, which then carry it to the dairy. And number four is transport of milk in cans by producer to a collection station, where it is cooled and stored temporarily and then transported to a dairy in tankers. So these are the four kind of transportation system followed in different places for the milk, which has got lot of impact on the quality and maintaining the microbial standard of milk. Now, temperature of milk during transport. When milk is transported in cans, there will be difference in temperature between individual cans. So there are so many number of cans are there, they will have differences in temperature. Whereas in a tanker, temperature is uniform throughout the bulk of milk. Temperature of milk in cans rise rapidly than in tanker. So when the milk are in different cans, the temperature rise will be more than in a tanker. Milk in 40-liter cans for 7 hours at 25 degrees Celsius may increase by 10 degrees Celsius, whereas in a tanker the rise may be only 1 degree Celsius. Milk becomes warm more quickly in grey polythene cans or plastic cans than in well-reflecting metal cans because of greater absorption of heat in plastic cans. So when we use plastic can, the absorption of heat will be more, so rise in temperature will be more, whereas in metal cans the heats will be reflected out, so the rise in temperature will be less. Now we will see the factors affecting temperature of milk during transport. The first is the degree of cooling of milk on the farm or collection center. As I said, either milk should be cooled in the farm or there should be temporary collection center. In these places it should be cooled. If it is cooled, then the temperature during transport or rise of temperature during transport will be less. Secondly, rise in temperature up to the arrival at the dairy due to outside conditions. So from the collection center or farm till it reaches the dairy plant, how much temperature will rise, that depends on the outside conditions like the temperature outside, that affects. Thirdly, the size of tanker vessel. What is the size? It could be 5000 liter or 10,000 liter or even less. So accordingly the temperature rise will be affected. And fourth is the time taken for transport, that is the distance or the time. If it is taking long time, naturally the temperature rise will be more during the transport. Now we will discuss about microbial growth during transport. As we have seen previously, during transport microbial growth can happen due to the increase in temperature, which depends on the cooling or duration or the atmospheric conditions. So when basic principles of hygiene is not followed, that will lead to the quality of milk during transport and subsequent storage deteriorates. And this happens more when cleaning of contact surfaces of milk during transport is poor, or when milk attains a too high a temperature, that is too much rise in temperature during transport will facilitate the microbial growth, and that will deteriorate the quality of milk due to the growth of microbes during transport. Here we will see the factors affecting microbial growth during transport. The first is the temperature of milk. As we have told at the beginning, the microbial growth depends on temperature. So if the initial cooling in the farm or in the collection center is optimum, then the rise of temperature during transport will be minimum. Naturally the microbial growth will be minimum. Second factor is duration of transport, that is how long milk is in the transport, and that makes a lot of difference because time and temperature together only is important for microbial growth, as we have seen at the beginning. Number 3 is level of contamination of milk, which we have discussed at the beginning. If there is very low contamination, then the microbial growth also very low, the lag phase will be long and the log phase will come at a very late time. And fourth, the number of CFU may show an increase through breaking bacterial clumps due to shaking during transport. So sometime we may get a more number of microbes that is expressed in colony forming unit, and sometime it may happen due to the breaking of the bacterial clumps. Now controlling microbial growth during transport. Here we will see some important points how to control the microbial growth during transport until it reaches the dairy plant, where actually it will be chilled first and later it will be pasteurized. The psychrotrophs derived from road tankers and ancillary filling and pumping equipment is a source of contamination during collection and arrival at dairy. So the psychrotrophs may get contaminated to the milk from these sources, which can cause the more microbial growth, so that we have to reduce. Secondly, transport of uncooled milk with number of microbes below 10 power 5 per ml at the farm. That should be our motto. And secondly, processing within 3 hours after its production. So we should be able to process the milk within 3 hours of production. And thirdly, maintaining temperature of 4 degrees Celsius during transport for daily, alternate or once in 3 days collection of milk. So we should be able to keep the temperature at 4 degrees Celsius to control the microbial growth during transport. Milk in no case should reach more than 10 degrees Celsius on reception at the dairy. So when the milk is finally reaching the dairy plant and being received, at that time it should never reach more than 10 degrees Celsius. This is in continuation controlling microbial growth during transport, proper cleaning and sanitization of bulk milk collection tankers and storage tanks immediately after emptying. So this is very important. The collection tankers and the storage tanks should be cleaned and sanitized immediately after making it empty. Using low pressure devices for cleaning. So we should try to use low pressure devices because high pressure devices may cause problem. Examining focal points of contamination and proper remedy to prevent contamination. So what are the important points of contamination? Those places we should inspect and take necessary action to prevent the further contamination next time. And changing rubber and plastic devices once in 3 months and suction hose every 6 months. So these are the source of contamination. So the rubber and other plastic devices should be periodically changed in 3 months and 6 months. So here we will discuss about storage in dairy plant before pasteurization. The milk coming from the farm or via collection center through milk tankers need to be stored and chilled before pasteurization. Samples of good quality milk through alternate day collection can be stored at 3 degrees Celsius up to 3 days. The milk of same quality could be stored at 5 degrees Celsius at the dairy for 1 day without significant increase in bacterial count. Daily collected milk having psychrotrop count 10 power 4 CFU per ml stored at 5 degrees Celsius exceeds 10 power 6 CFU per ml in 3 days of storage. So here the milk should be stored with chilling immediately it reaches to dairy plant until pasteurization, and then this stored chilled milk will go for pasteurization later on. So these are some of the details about the storage of milk in the dairy plant. Here are some more details about the storage of milk in dairy plant before pasteurization. Milk containing CFU 10 power 6 per ml, that is colony forming unit, with 2% psychrotrophs can also be satisfactorily stored at 5 degrees Celsius for 2 to 3 days before pasteurization. Alternate day milk collection followed by storage at the dairy for 1 to 2 days at 4 degrees Celsius, or collection every 3 days followed by storage at 4 degrees Celsius for 1 day are both satisfactory system. For longer storage period, the milk should be thermized, that is heat treated at the dairy 63 degrees Celsius for 10 seconds to destroy the psychrotrophs and enhance storage life by 2 to 3 days at 5 to 6 degrees Celsius before use. So for any reason, if we cannot go for quick pasteurization, we can go for a short heat treatment like 63 degrees Celsius 10 seconds, and that can increase the life for 2 to 3 days at 5 to 6 degrees Celsius. Here we will see the microbial growth during storage, that is in the dairy plant before pasteurization. So microbial count is not always as decisive as composition of flora, because what kind of microbes present, that is very important, especially in case of cold storage. The psychrotrophs are very important. Milk for direct consumption should be free from bacterial spores and free from objectionable taints. So this is very important. Due to microbial growth, it may give different kind of taints. Some of the proteolytic and lipolytic enzymes excreted by psychrotrophs continue to work at 0 to 8 degrees Celsius and cause variety of flavor defects such as fruity, rancid, stale and bitter flavor. So this is very important, particularly growth of psychrotrophs. And organoleptic changes can be detected when microbial load reaches above 10 power 6 per ml in cooled milk and 10 power 7 per ml in uncooled milk. So this is the last one, how to control the microbial growth during storage in the dairy plant, that is before pasteurization. The practice of partial emptying of silo tanks should be avoided. So we should not have partial emptying and leave some milk there. That will cause growth and then cause contamination and affect the quality. Cooling and refrigerated storage does not solve the problem of growth of psychrotrophs. So this is only a temporary measure before pasteurization. So once the milk comes, it has to be chilled and stored, but it is for short time. Ultimately, the pasteurization is very important and it should be done at the earliest possible. By combining techniques of heat treatment of milk, that is sub-pasteurization, on farm prior to storing in bulk tanks at 7 degrees Celsius, the growth of psychrotrophs can be controlled for few days. So sometime if it is difficult to pasteurize quickly or difficult to reach the dairy plant quickly, then sometime it is advised to have a sub-pasteurization in the farm itself before it is stored in the bulk tanks. So this is about the control of microbial growth during storage. So now we are at the end of today's lecture. I will just summarize. Today we have discussed about the microbial quality aspect of milk and how to maintain the quality. So we have discussed about the microbial contamination at the milking shed or at the farm level and different aspects of microbial growth, the phases of growth like lag phase, log phase and stationary phase, and how the microbial growth is affected by temperature and time. And then we have discussed about the quality of milk at different conditions like the clean condition and unclean condition in the farm. We have seen the effect of temperature on microbial growth and time, and we have discussed details about the microbial growth during transportation and the factors behind that, and how to control the microbial growth during transportation. And finally, we have discussed about the microbial growth during storage in the dairy plant and how it is affected, how the microbial growth affect the quality of milk, and how to prevent the microbial growth during storage in the dairy plant, that is before pasteurization. Thank you.